Hello. So today we will understand the chapter 13, that is loading and pre-processing the data with TensorFlow. This is part of Unit 3 in your syllabus and it is a part B. So the part A is completely based on customizing models and the TensorFlow basics. So in part B, we will understand about loading and pre-processing the data with TensorFlow. So we need to understand why exactly this topic is included in deep learning. So what is the motivation behind including this chapter? So far in deep learning, we have used the data sets which is directly downloaded from some other disk, and we started using those data sets to for the model building activity. But in case if we have a very large data set that does not fit into the memory, so how you pre-process the data, how will you build the model? All those will be a tricky question to us. In order to solve that problem, the TensorFlow has provided with the data API concept. So data API and TF record formats are those concepts that helps us to create the data set on our own. So we can simply create our own data set. We can pre-process the data. We can read the files, either the CSV file or we can read the binary format file and transform it using the TF function. So this TensorFlow helps provides us data API is one of the very important concept in deep learning. They even take care of multi-threading, batching, prefetching. We'll see what is batching, what is prefetching, everything in this data API. There is one more concept that is TF transform in this chapter, which is a concept that helps us to write our own pre-processing function, and one single pre-processing function can be run helps us to we can apply this pre-processing function on the complete data set, can be a training data set. Okay, and after applying the pre-processing function, if it is working properly, we can export it into a TF function and then import it into a trained models. We can then, once everything is working properly, we can deploy it onto the production. This pre-processing function can take care of any new instances on fly in production. Next one is TFDS, that is TensorFlow data sets. There are few data sets which is freely available. We can download all those data sets and create a project. So these data set could be a small ones like MNIST or a fashion MNIST to a very huge data set that is the ImageNet. So you can download all these projects, you can download all these data sets using in from the TensorFlow data sets and create a project out of it. So these are the few important points required to understand this chapter. So let's proceed further with data API. In data API, we are going to understand few subtopics like chaining the transformations, shuffling the data, pre-processing the data, putting everything together, prefetching, and using the dataset with tf.keras. All these six subtopics under data API we will learn in detail. Let's begin with the introduction to data API. We all know that from machine learning to deep learning, we basically work on the dataset concept. So this dataset is nothing but a collection of features and the instances. And we download these datasets to our disk and we work on it. Now, if you want to create the dataset on your own, entirely in the RAM, which that's the memory which in which you working, you can do that using functions or the methods provided by the TensorFlow. So in order to create the dataset, we should use tf.data.datasets, and that is suffixed with few other functions, that is from tensor slices or range. Now this tf.data.dataset helps us to create a dataset, whereas the functions such as range helps us to list the sequence. It creates the sequence of numbers. So it returns the it basically range is a method which creates the sequence of numbers and it returns one dimensional tensor, whereas from tensor slices is a method which slice the items which is there in the data set into a one dimensional tensor. Let's understand this with the help of a small example here. We are going to create a data set, data tensor X, by using the method tf.range, and the value which is passed as an argument is 10. So what happens here? It creates one dimensional tensor with the items ranging from 0 to 9 when you execute the first line. So when you go to the next line, and basically in the second line, what is happening is we create a data set from tensor slices method by passing x as an argument. X is nothing but a one dimensional tensor. So that is given as it is not a one dimensional, it is a sequence of numbers from 0 to 9. Let me correct it once again. That is tf dot range of 10 is giving you the sequence of numbers from 0 to 9. So it creates a data tensor called as x. So that x is taken as an input to from tensor slices function, and it creates a new data set by slicing the items which is there in the data x, that is the data tensor x. Okay, and then it creates a data set. So this data set is of the type int32. Now in case if you want to print all the items which is there in the data set, you can just use the for loop over the item in the data set and print the items. So it prints all the items from 0 to 9 as one dimensional tensor. This is one way of creating a dataset using range or from tensor slices. So one more point here is, instead of executing tf.range of 10 separately, you can replace from tensor slices with dot range. that is tf.data.dataset.range of 10. And even you can produce the, this also produces the same result. That's about data API. Let's understand what is the meaning of chaining transformation, which is part of data API. Now we have created a data set. It contains the numbers from 0 to 9, and we can apply all sort of transformations such as repeat, batch, unbatch, map, lot of other methods onto the data set using the transformation methods. Each method, that is the transformation method that we apply, return a new data set. Okay, now let's see how we are going to apply repeat and batch methods onto the existing data set and how it creates a new data set. In this, here you can see that data set which was created earlier using the range and from tensor slices methods, which is a sequence of numbers from 0 to 9, that is a one dimensional tensor. On top of that, we are applying a repeat method. So what this repeat method does, so it repeats the data set for 3 times, as we are passing 3 as an argument. It repeats the same data set, that is 0 to 9, 3 times. And then on top of this repeat, you're going to apply the batch method. This batch method is splitting the data what we have into 7 items in a batch. Okay. After this, you are printing the tensors. That is, as I told you, it is repeats the data set for 3 times. That is from 0 to 9, then 0 to 9, and then 0 to 9. And on top of this repeat, you are applying the batch. That is, you are going to batch the items, 7 items in one batch. That is, we have 0 to 6 in one batch, 7 to 3 in another batch, 4 to 0 in one batch, same way for the other two batches. And the last remain batch, which is the remaining items 8 and 9 from the data set. These are the only two numbers which are left, and that is part of the last batch. This is with respect to the Python code. Now, let's understand this with the help of a diagram here. From tensor slices of x, which helps to create the one-dimensional tensor for a given value from 0 to 9. And this data is repeated 3 times. Okay, so you're going to repeat the data set 3 times using the repeat method. And then you are applying the batch concept or a batch method, wherein which the 7 items in a batch, 7 items are grouped in the form of a batch, and it is returned. This kind of steps that we have applied, repeat and batch, is a kind of chaining the transformations on the data set. There is one more point here, that is, you can see in the last batch there are only 2 items, that is 8 and 9. But the we need to remove, or we can drop these remainders by you setting drop remainder equal to true. Now why we need to drop these 2 items? Because all the items which is there in the batches should be equal in size. So better to drop the items 8 and 9 from the last batch by setting drop remainder equal to true. Okay. Now let's move on with the next transformation method, that is map. So map is a transformation method which again creates a new data set by transforming each item present in the data set. We already, the value of x, which is the range of values from 0 to 9, is already created earlier. That is a data tensor. So on top of this tensor, if we apply the map method, which is using a lambda function, that is x into 2, which is nothing but you are multiplying each value of x with 2, and that returns a new data set by doubling the items. So the output of this particular line would be, it would be returning double of the existing values. That is, the first value of x was 0. So 0 into 2 is returning you 0. Next value was 1. 1 into 2 is returning you 2. Next value is 3. Next value is 2. So 2 into 2 is returning you 4. Next is 3. 3 into 2 is 6. Same way it continues. Now, what is the point of including this map method? This map method provides us arguments such as num parallel call argument. That is, this num parallel call, if we set this option or this argument to true, what happens is that you can speed up your processing by making use of multiple threads. That's a very important argument in map method. And one more point to be added is that if in case you have a data set which consists of images, you can use computation such as reshaping or rotation of an image. And then on top of that data set, you can apply the pre-processing using the map method. Okay, so map is a method which helps us to create a new data set. And we have seen the transformation on each of the item using this lambda example. Okay, that's about map method. Now let's move on with the next method, that is apply method. Apply method is a method which again we use it for the transformation on the data set as a whole. That is, we are not going to apply the transformation on each and every item when compared to the map method. Instead, we are going to apply this transformation as a whole on the whole data set. For example, we can apply unbatch method to the data set, where that is to the data set where in which it can unbatch the tensor. For example, the previous data set that we have generated was a one-dimensional tensor. So when we apply the concept of unbatch to that one-dimensional tensor, okay, let me correct this example here. In the previous data set that we have generated, that is a batch of 7 items in one batch. So what we are going to do, whatever we have batched, that is 7 items in one batch, will be unbatched, and it can be in the form of a single integer tensor. So we are applying the concept of unbatching method onto a batch batched data set. So this will give you another data set. So the transformation method that we have used here is apply. Okay, let's move on with one more method, that is filter method. This filter method can be applied onto the data set to filter out few items. For example, on the existing data set X, if on the existing data set, if you apply a filter like a value less than 10, then it prints you all the items which is less than 10 from the data sets. So it will return you 0 to 468. And the next method is the take method. Take method is like, if instead of printing all the items which is there in the data set, you can just print the first few items from the data set. That is take of 3. So it will print you the first 3 items from the data set. Okay. So that's about the chaining transformation. So in chaining transformation, we have seen a repeat, batch, map, apply, unbatch, filter, and take methods. Using these methods, we can create a data set, create a new data set, and transform the data set. So the next topic is shuffling the data. Here, this is one of the simple way to ensure that we can shuffle the instances using the shuffle method. Okay. So, so in this shuffling the data concept, we create a new data set by using the buffer. We take the buffer and we update the buffer with the items which is there in the data source data set. So whatever items are there in the source data set, we copy the item until the buffer is full. Whenever user is looking for the items from this data set, from this source data set, the items from the buffer will be returned instead of source data set, and the item which is returned from the buffer will be filled up with the next item from the source data set. And this continues until all the items from the source data set is completed, or until the buffer is empty. Here we need to specify the buffer size. That's the most important thing. The buffer size should not be greater than the dataset size, or it should not exceed the memory size or the RAM size. Okay, that's about the buffer. Now let's understand this shuffling concept with the help of a Python code. Now we have used range and repeat earlier in chaining transformation topic, and we have created a new data set out of it. On that data set, we will apply the shuffle method. This shuffle method would take few arguments such as buffer size. Here the buffer size is given as 5. 5 means that the buffer can hold 5 items, and we have given the random seed as 42. A random seed is like you want to repeat the same order, or you want to retain the same order. So we have given the random seed as 42. After applying the shuffle method, it will be proceeded with the batch method. Again, you are batching the data. In one batch, it will have 7 items. Okay, and then you're printing the items, one item at a time with one batch. Here you can see the data is already shuffled. The data is shuffled because you have applied the concept of shuffle with the buffer. So it is printing 7 items in one batch. Same way it will have 4 batches because you have repeated the data for 3 times. And the last batch is now having 3 and 6. Okay. Uh, as we have understood how shuffling works with the concept including the buffer. Now, why this shuffling and buffer concept in data API? For a larger data sets which does not fit into the memory, this simple shuffling buffer approach may not be sufficient enough because the buffer will be small compared to the data set. One solution could be to shuffle the source data set, or you can split the source data set into multiple files and then randomly read the files in any order during training. Okay, so let's understand this splitting of the source data file into multiple files and read it randomly, read them simultaneously in a random order using interleaving the their records. So we are going to understand the concept of interleaving along with the shuffle method. Suppose for interleaving, we are going to load the California housing data set. Let us just the assumption right now. Suppose load the California data set. The data is shuffled unless it is already shuffled. Split the data set into training set, validation set, and the test set, and split each of these sets into many CSV files. Okay. Now, when you print those sets, that is, when you print one of the CSV file, it contains the data like this. That is, it includes all the 8 features along with the dependent feature. All these values, that is, these values are um, after using shuffling and splitting, it looks something like this. Okay, so these are the actual values which is from the data set. Now, with interleaving concept, that is, we are going to consider the train file paths, which contains the list of training file paths. That is, the train file paths contains all the training file paths in the form of CSVs. For example, if we print train file paths, it includes all the files, the training files starting from 00 up till the based on the data, so many training files will be created. Now you can just use the pattern that is star.csv in order to print all the files. Here we can create a data set called as list files using tf.data.dataset followed by list underscore files. This includes all the file paths from the training file path with the random seed as 42. By default, this list file returns a dataset. So this list file function by default returns a dataset which include the shuffled file paths. If we set shuffle equal to false, then the files will not be shuffled. If we can go with that option as well if we want. Now we need to understand the interleave method part. So this interleave method, what we are doing here is we will first read the we'll read from 5 files at a time. We are going to read first 5 files at a time, and we are going to interleave the first line from each file. So why are we interleaving or skipping the first line? Because it contains the header row. So we need to skip the first line from each and every file. So this interleave will create the data set. And then we will call the lambda function which creates again a new data set called as text line data set. So it includes the file path with the skipping the first line. Okay, here in this basically we have created list file as one data set. We have created interleave data set. List file includes list of all the training files, and interleave dataset includes all the files or only the 5 files at a time. Okay, list file all the files, whereas interleave includes 5 files at a time. And next we have created a text line dataset, which this dataset includes the data with the by skipping the first line. And this continues until all the training files are interleaved, or we have read the complete training files. By default, this interleave will not include the parallelism mechanism. That is, it reads one file at a time sequentially. If you want to read all the files in parallel, you can go with the argument called as num parallel calls. If we set this parallel calls to true, we can read all the files using multiple threads at the same time. Okay, and one more option that we can use is that tf.data.experimental.auto tune. When we use this method auto tune, the TensorFlow can decide on its own about the threads. That is, it can open the right number of threads dynamically based on the available CPU. Now let's print the lines which are part of text line data set. Using the take method, we are just printing the first 5 lines, and this is the data which is part of the text line data set. Let's understand the concept of pre-processing the data, which is the third subsection of data API. In order to pre-process the data, that is, we have considered the California data set, we have written a small function to it. So before beginning with the method pre-process, there are 2 lines that needs to be executed before that. The first line, which is we are in the first line, we have calculated the mean and standard deviation for each of the features in the training set in the first line. That is the x mean and x standard deviation for each feature in the training set. So this x mean and x standard deviation, it returns one dimensional tensor consisting of 8 floats, one per input feature. And in the second line, it is n inputs equal to 8. So 8 is the independent features in the California data set. Now let's move on with the pre-process method. This pre-process method takes one CSV line at a time. So one line at a time from one CSV. And then it starts pre-processing it. Now we'll understand the second line which is there in the pre-process, that is tf.io.decode CSV. This method takes two arguments, line and record defaults equal to default value. So the first argument is the line, that is to parse. So we have taken the first line from the CSV for parsing. And the second argument is the default value for each column in the CSV file. So getting the default value for each of the feature is from the first line in this particular function preprocess. So the first line tells you that it returns you the value 0 if there is no default value associated with the feature. Here all the features are of the type floats. So the missing value will be defaulted to 0 if in case there is no default value associated with the feature. And the target column, if in case there is no default value in the target column will raise an exception if it is a missing value or if it does not have a proper value to it. That's about the first two lines. This decode CSV, it returns the list of scalar tensor, one per column, but we need one dimensional tensor array. So in order to return one dimensional tensor array, we are using tf.stack. We are using tf.stack here on all the tensors, that is the input independent features. So x represents your independent feature, y is your dependent feature. So for all the independent features, we are using tf.stack so that we can return one dimensional tensor array. And same thing for the dependent feature for the California dataset, that is y here. So in order to return the target value in the form of one dimensional tensor, we are using tf.stack here for the last target column. And finally, we scale the input feature by subtracting the feature mean and dividing it by the standard deviation. That gives the value of x followed by y. So we return the tuple here, x and y. That is the scaled feature. That's about the preprocess function. Now, so the details of the preprocess method is given in this slide. Now, if we use one particular line from the CSV and pass it to a preprocess function, it is giving you a one-dimensional tensor that is the ID of it, the tensor ID, and the shape is like 8 features, independent features, and it is of the type float 32. This is the NumPy array. That is the scaled feature value. That's about the pre-processing the data, which is the third subtopic in the data API. Let's understand the fourth subsection in the data API, that is putting everything together. In the previous subsection, we have seen the different methods being used, such as repeat, batch, shuffle, map, the list files, interleave. All these are the methods that we have used earlier in the previous subsection. Now we are going to combine all of these and will frame one function to it. So before writing the function, let's understand this diagram with respect to the California housing data sets. So the very first thing that we are doing with the data set is that we are going to generate the multiple CSVs for a different set, that is a training set, validation set, or a test set. So the list file is a data set which contains the multiple CSVs. So this list files, we are repeating it in the form of batches and then passing on to it to a interleave method. So this interleave method, what it is doing, it is going to remove the first line of each and every CSV, which is the header row that is being removed, and it creates a new data set to it. This new data set is shuffled, and then we apply the concept of pre-processing. We apply the concept of pre-processing that we have learned in the previous subsection to scale the features and to generate the proper value, the scaled value. After applying the pre-processing, we are going to apply the batch method. So we are distributing it in the form of batches, and then the last method that we are going to apply is the pre-fetch. So let's understand, or let's write the function with all these methods together. So we are giving the method name as CSV reader dataset. So this takes few default arguments. It takes the arguments along with some values to it, the 5 paths, and we are considering repeat here equal to 1, and the number of readers, that is 5 files at a time from each of the CSV. The number of read threads is equal to none here. That is the number of threads we are going to run in parallel in order to improve the processing. But right now we have given it as none. And the buffer size used for shuffling is given with some value, that is 10k. And the number of parse threads is given as 5. That is again a number of threads which we can run in parallel, and the batch size is given as 32. So let's create a data set using the list files, passing the file paths. So we know what is file paths. We have already discussed in the previous subsection. So file paths can include the list of files or the CSVs for the training set or the validation set or the test set. That is given as an input to the list file method, which generates a new data set. To this new data set, we are applying the interleave method. In this interleave, we are skipping the first line, and then we are including only the text lines to this data set, for which we are applying the number of files that needs to be read at a time and the number of parallel calls, that is we can read these files parallelly to improve the processing. After which, after removing the first line, we are applying the map method here. So this method is what it is doing. It is calling the pre-process. It pre-process the data by either parallelly or sequentially. After this map method, we are applying the shuffle. We are shuffling using the buffer size and then apply the repeat method to it. At last, we are applying the batch with 32 as a size and the prefetch method. Now we don't know what is prefetch. So we will learn prefetch in the next subsection in the next slide. So before getting into prefetch, so we have covered the list files, interleave, map, shuffle and batch, which is part of CSV reader dataset function. So this is how we put all these methods together to create and return a dataset efficiently for the California housing dataset. Now let's understand what is prefetching. So in this prefetching, you can see three different diagrams here. One is without prefetching, one is with prefetching, another is with prefetching with multi-threaded loading and pre-processing. So let's understand this first diagram. So in this first diagram, what we are doing is that we are first preparing the data set. So CPU is used to prepare the data set per batch, and then we are giving it to GPU for training. So this is going on sequentially, one at a time. We'll prepare the data set and then train it. After training, again we are preparing the data set and then training. So this goes on. Here, the without prefetching, the as the data, the work is in sequential way. So it takes time to complete the training. Now, if we apply prefetching to the data set, so what happens? For every batch, the data is prepared. Basically, for the first one, we first prepare the batch and then we train the model for that particular batch. And parallelly, the CPU is preparing the data for the second batch. So preparing the data and model. So model building is going on in parallel. So CPU is also working and GPU is also working. So both CPU and GPU work in parallel, one batch at a time. Okay. So it is pretty faster compared to the method without prefetching. So let's understand the third one. Here we, along with prefetching, we have included the multi-threaded concept. That means we can use all the available CPUs for preparing the data per batch and then train it using GPUs. That's the concept of prefetching. So this prefetching is included in our previous definition, that is CSV reader dataset. Now let's move on with the last topic in Data API, that is using the dataset with tf.keras. We have used CSV reader dataset function to create a dataset for the training set. And in this CSV reader dataset, we did not use repeat. I mean, repeat is given the value as 1 because the tf.keras take care of all this stuff. So we did not use repeat with some other values. Now this function CSV reader dataset can be applied on different file paths such as training file path, validation set, and the testing file path. And we generate the train set, validation set, and the test set. So for all these set, we can use it for the model building activity. So we can build and train the Keras model by using these training, validation, and test sets. So what we are doing now, we are going to build the sequential model and then compile the data, compile the model, and then fit the training data, train the model on the training set with the proper arguments what is required. And the last one is evaluate and predict methods. Here we have used evaluate method on the test set, and then in order to predict it, what we have done, we have used a lambda function. So pretending we have three new instances, and we create a new set using the map method and take only the first three values using the take method, and we pass a new set to the predict method. So it predicts the values. So the model will predict the values. So this is how using data API we can create the data, we can transform the data, we can create a separate definition for pre-processing, and then build the model and test the model. Okay, that completes your data API, which is part of the third unit, part B. So in the next slide, there are few TensorFlow functions. Just go through it, like what map does, what range does, and shuffle. That completes your first topic, that is data API.